All right, guys. Hi, this is Mr. H. I wanted to go over a quick lesson for today, and then I want you guys to work on. I think there are like 10 questions that are taken from old Regents exams, because I want you to see what kind of questions the Regents people like to put on there to test whether you know rational versus irrational. Um, the simplest thing that I can say here is when you're looking at numbers that have square roots in them, you always have to determine, is the number inside the square root a perfect square or is it not a perfect square? Because once you know that, you can tell whether it's rational or not. So if I look at this number, I'm going to start with this. If I said, is the square root of 4 rational or irrational? You should say, well, this is a perfect square inside the square root. So that means this is going to be a rational number, and the actual number is 2. If I say it's the square root of 5, is that rational or irrational? The number inside the square root is not a perfect square, so that means that the answer or the number is irrational. So that is the key idea when you're trying to determine whether something is rational or irrational. So now let's look at a question. Now this question was taken from an old Regents exam, and I want to kind of walk through how I would do this. Very first thing that you see here is that they've given us variables and then they've given us values for those variables, but all of the values have square roots in them. So it says L is equal to the square root of 2. Is 2 a perfect square? No. So this number is going to be irrational. I know that. Same thing for M. M equals 3 times the square root of 3. Is 3 a perfect square? No. So this entire thing is going to be irrational. Okay, and then I look at N. N equals the square root of 16. Is 16 a perfect square? Yes, it is. So the square root of 16 is equal to an integer, which is a rational number. So this is going to be rational. Same thing for P. Is the 9 a perfect square? Yes, it is a perfect square, so this number is going to be rational. Now, the only way that you can add two numbers and get a rational number is if both of the numbers are rational. So these two numbers are both rational, so I can add those two numbers together and I will get another rational number. So the answer for this is 3. Now I'm going to walk through, let me change the colors, the rest of this. So if I add an irrational number to a rational number, or this is also an irrational number, I'm going to get an irrational number. Now, the second one, if I add an irrational number to a rational number, I still get an irrational number. The only way that you can get a rational number is if you add rational numbers. That's the only way. Now, here in 4P is a rational number, but L is an irrational number. So when I add a rational number plus an irrational number, it's going to be irrational. And that's it. So that's how you would do that. Now here's another example. It's basically the same idea. They've just presented it a little differently. What you should be doing is going through and identifying what's rational and what's irrational first, and then determining, am I adding those? Am I multiplying those? And then what should happen? So I'm going to start with number 1. So a negative 5/8, that's a fraction. All fractions are rational. 3/5, that's a fraction. That number is rational. So when I add two numbers together that are rationals, this entire thing, this entire expression is going to be rational, or the sum is going to be rational. Now, if I go to 2, 1/2 is a rational number. The square root of 2, since this is not a perfect square, this is going to be irrational. So when I add a rational and an irrational, just like in the example before, I get an irrational number. So it's going to be irrational. The sum is going to be irrational. Now, number 3, this we're multiplying. Now, the only way for us to multiply and get a rational number is if the numbers inside, when we multiply them, is a perfect square. So if we multiply 5 times 5, this is going to be the square root of 25. So we're going to take this 5 and multiply it with that 5. So is this number a perfect square? Yes, it is. So that means that this is going to be a rational product. Okay? And finally, for number 4, I've got 3 is a rational number, and I've got 49. 49 is a perfect square, so this is going to be rational or rational. So when you multiply a rational with another rational, you get a rational. Okay? Rational times a rational gives you another rational. It's like going 3 times 4, you get 12. You can never multiply 3 and 4 and get an irrational number. It's always going to be, if you multiply 2 integers, you're always going to get another integer. You'll never get a decimal or a fraction. If you multiply 2 integers, you'll always get another integer. When you multiply 2 rational numbers, you're always going to get another rational number. That's the rule. So now the question is, which one of these is going to be irrational? We've already looked at it. It's only choice 2, so our answer would be 2. Okay? Guys, that's how you need to do this. Always start, especially when you're looking at square roots, determining if the number inside the square root is a perfect square. If it is a perfect square, then that number is going to be rational. If it's not a perfect square, then it's going to be irrational. And then you just work through that. Okay? I hope this has been helpful. And hopefully I'll be back tomorrow, if not Monday. But I'll go back over this if you guys have questions. But hopefully this is good enough for you. All right, guys. Take care.